Hi everybody, this is lesson 8A2, which is solving and graphing linear inequalities. So we've been working with inequalities. Remember that with inequalities, there's more than one answer. There are a bunch of answers. And so we're going to be investigating that a little bit more of how many answers are there. So here's a question. Is the 2, 4 an answer or a solution to this problem? Remember that this is my x and this is my y. So how are we going to know? Well, the way we know is we're going to plug it in. So if I plug in a 4 over here, and I'm keeping my less than sign, and I plug in a 2 in for x, and now I want to work this out, and I might need a calculator to help me work this out. And so with my calculator, I might multiply 3 over 2 times 2, and so that gives me 3, and then plus 1, and so what I have is 4 is less than 3 plus 1, well that's 4. Okay, so there's a question for you. Is 4 less than 4? No, 4 is not less than 4. 4 is equal to 4. If they have an equals with it, maybe, but this is a less than. Okay, so then the question is, well, what is a solution? What point would work? And so we're going to talk about that here in just a second. Let's go to this problem. And again, remember this is your x and this is your y. Is this a solution? How do we know? Well, the way we know is we plug it in. So we plug in an x is negative 2. And we plug in a y is 1. Is this greater than or equal to 6? Actually, that's a negative 6. So let's plug it in and work out. So negative 2 minus 2 greater than or equal to negative 6. On your calculator, what's negative 2 minus 2? It's negative 4. Is negative 4 greater than or equal to negative 6? You have to think of your number line. And some of us are pretty good with our number lines, but some of us probably aren't. And so this is my 0, let's say. So 1, 2, 3, 4, 5, 6. So here's negative 6, here's negative 4. Is 4 greater than? Yes, it is. Negative 4 is greater than negative 6. Why is it greater? Because it's farther to the right. Anything far to the right is bigger. So yes, that is greater than negative 6. Is it equal to? No, but it's greater than or equal to, so it works. That's not the only answer that works. There are a bunch of answers that would work in this. That's what inequalities do. Inequalities give us a multiple number of answers. Bunch of answers. Okay, let's go back and recall. This is probably something you've learned before, but basically, if it does not have an equal to, you use a dotted line. And that's like when we were doing on the number lines, we would have open dots. Okay, if an open dot or a dotted line, that means it does not include the points on that line. If there is a solid line, then we have a closed dot, and that means it does include that point. And so anytime there's an equal to, we put a solid line, and that means it does include the points on the line. And again, we're going to talk about what this all means here in just a second. Where to shade? We're going to talk about how to shade it. Basically, less than or less than equal to will usually go below the line, because below is less than. If it is greater than or greater than equal to, it will usually go above the line, because above is more, this is greater. However, this really only works if it's in slope-intercept form. If it's not in slope-intercept form, we have to figure some other things out. Okay, so let's try to pull some of this together. This says let's try to take a picture of all the solutions of these same two problems. So this problem, y is less than 3/2 x plus 1, that was the same problem I had up here. And we decided that the point 2, 4 was not a solution because it was actually equal to. Let's investigate that a little bit. Because there are an infinite number of solutions. Where are all of the solutions? Well, first thing we're going to do is we're going to graph this point. And so we're going to graph it by starting at the 1 on the y-axis. We're going to go up 3, right 2. And we can do it again, and we can do it again, and so forth. Okay, I'm going to use a straight edge to connect my line. But before I do, I want to think about it. Should it be solid or dotted? There is not an equal to with it, so it needs to be a dotted line. So this line that I have here is bad. I need to go back and erase. So that's a bummer when you have to go back and erase, right? Okay, so again, because of this, there's no equals. Because there's no equals, it's going to be dotted. That means that those points on that line are not included. Maybe I should say it doesn't include the points on the line. So here are the points the line, but it does not include the points on the line. And why? Well, let's go back up to the top. The point 24, let's find that point 24. The point 24 would be 2, 4. It would be this one right here. And we just said up there above that that should not be an answer. Why not? Because it equals. The points on the line are the points are that would make it equal to. And we do not have an equal to, so the points on the line are not included. That's why we do the dotted line to show those aren't really part of the answer. Okay, now the shading. It says less than. Less than means below. So we're going to go below. And you might say, hey, that doesn't look like below. That looks like to the right of. True, but let's think of it in terms of on the y's. In fact, I'm going to erase all those lines. When I say below, I'm talking about like from the y's. Like look at the y's. We're going to go below this way. Everything below it going on the y-axis is part of the answer. What does that mean? It means any point in this area that I've shaded, any point, any one of those points, if I plugged it in, would be less than. Less than. If it's on the line, does not work because it's equal. If it's over here, does not work because it would be greater than. I'm going to try another one of those just to make sure we know how to do this kind of a problem. So I'm going to graph it. I'm going to start at 5. I'm going to go down 2, right 1, down 2, right 1, down 2, right 1, etc. I'm going to connect my points. Should it be solid or dotted? I have to pay attention. This is going to be dotted again. So I need to make a dotted line. Okay, here's my line. I have to figure out which way to shade. This time the shading says up. It says greater than. If it's greater than, it gets shaded up. So up, what do I mean by up? Well, I look at my y-axis and I go up from my y-axis. So it's this area in here. What this means is any single point in here, every single point in here would make this inequality true. It would come out to be greater than whatever is over here. If it was on the line, it would be equal to, and if it was over here in this space, it would be less than, and we're not looking for less than, we're looking for greater than. So that's the above part. Up here to number 4. When we did problems like number 4 before, we did them with the cover-up method. And so like we would cover up the x, and so we divide by 2, and we get y is negative 4. And then we would cover up the y, and we divide by 4, and we get x is negative 2. And so if we plot these, we plot the negative 2 here, the negative 4 here, and now we need to connect them with a straight edge. So we're going to connect them with a straight edge. When I connect them with a straight edge, I have to decide, should I do a solid line or a dotted line? The equal to with it tells me I have to do a solid line. So I'm going to get a solid line, and I'm going to connect these points and make my line. So here's my line. Now, we still have to decide whether we should make that line, hang on. Okay, we still have to decide which way to shade the line. So even though we did the cover-up method before to do this, on these, it might be easier to change it to slope-intercept. And the reason why is, I said this a little bit ago, that we're going to shade it lower than if the equation is y equals or y is less than. So as y is less than, we go y less than y down here. Y is greater than, we go above the y up here. This one's not in y equals, and so I really think it's going to be better to change it. Let me show you what I mean. We're going to subtract 4x from both sides, and we've done this before. This is not new. Now we have 2y greater than or equal to negative 4x minus 8. I'm going to divide by 2, and I get y greater than or equal to negative 4 divided by 2 is negative 2x, negative 8 divided by 2 is negative 4. All right, let's take a second to look at this. If I were to plot this line, I would start at negative 4, which is where I did, and I would go up to left 1, up to left 1. And so this line that I just came up with right here, this equation, matches the line I already had. And the advantage is now it's in y equals format. And so it says y is greater than or equal to. That means that I can shade on the y side, on the greater side. I think that's going to be the easiest way for us to do this. And once again, remember what this means is, this means that any point on this side, if I plugged it in, it would be greater than or equal to -8. Anything that I plugged in from the line itself, it would be equal to -8. And anything I plugged in over here would be not equal, be less than -8. So those would not work. So again, even though we did the cover-up method, I think on this one, it's going to be easiest to change it over, just like we did over here. So let's go ahead and do that. Let's subtract our x from both sides. So we have a -2y greater than or equal to -x minus 6. I'm going to divide by -2 on both sides. Now, when I do this, remember our rule with signs? That when you divide by a negative, you have to switch the sign the other way. And now this is going to be a positive, because a negative divided by negative is a positive 1/2 x. This is going to be a positive 3. So when I go to graph this is at 3. I go up 1, right 2, and I make a bunch of dots that way. And I can go down 1, left 2, because negative makes positive. And now I need to connect those with a line. I have to think about, should it be solid or dotted? And the fact that there's an equals tells me it has to be solid. So I'm going to get my straight edge and I'm going to make a solid line. Now, because I've already changed it over, I can very easily shade it the way I want to shade it. And the way I want to shade it says less than or equal to. So I go to the y's, I go lower than on the y's. So it's everything on this side that I'm going to shade. Once again, what that means, any point in this area that I plug in, it would be greater than or equal to -6. If I plug in a point on the actual line, it's going to be equal to -6. Stuff up here will not be greater than or equal to -6. That's what the shading means. Okay, on the next page we only have 2 more, and they're very basic. Sometimes people get confused because they're so basic. Y is greater than or equal to -4. So we have to remember, does it go across? Does it go up and down? Well, here's my Y. And so if I go to -4 on my Y, it is here. And now which way do I go? Do I go up and down or across? Well, up and down doesn't really make sense. What you want is you want to keep all of the Y's. Oops, I need to go straighter than that. I'm going to get my straight edge. You want to keep all of the Y's at -4. So here's my line. It's at -4. Everywhere it hits, it's at -4 on the y-axis. It says greater than. I'm going to go back to what I was doing before. If it's greater than, it's above on the y's. So it's up here. So this is my shading. This makes sense. Everything up here that I would pick, if I plugged it in, it would be greater than -4. Everything down here wouldn't. So it's not shaded. Last one, x is 6. X is less than 6. So we go to the x-axis. We go to the 6 and we put a dot at 6. And we want all of our x values to be 6. So I'm going to go up and down. And it says less than. So, oh gosh, I made a mistake. What did I do? I made it solid. It's supposed to be dotted. Let me change it to dotted. Okay, change it to dotted. It is less than. Less than is to the left. Now, I've been saying up the whole time. This is the only time you don't go up, because how could you? You can't go up. But x is less than 6. That means it's going to be over here. So I'm going to shade this area over here. And again, what it means, anything over here, if I plugged it in, it would be less than 6. Anything on the line would be equal to 6, and that's not part of the deal. It's no equals. And anything over here would be greater than 6. And I don't want those, so I did not shade on that side. All right, we'll practice this in class.